The Tessonics acoustic microscope can operate with a variety of standard immersion transducers. In this example, a spherically focused 30 MHz acoustic lens with a focal distance of 12 mm will be used. The transducer connects using a UHF connector, which is strong enough to hold the transducer in place while it is being moved back and forth when taking measurements. In order to get the best acoustic image, it is important to select a transducer with the correct optical frequency and focal distance. The transducer is inserted into the connector and secured with the tightening nut. The container is filled with a coupling fluid. In this case, regular tap water is being used. The water has been allowed to sit undisturbed in the bottle for a day in order to settle and remove dissolved air. For this demonstration, we will be looking at a spot weld coupon. This is two metal plates, roughly 2 mm in thickness each, held together with a variety of spot welds ranging from 2 mm to 8 mm in diameter. In the spot welding process, the metal from the two plates is melted together in order to form a fused area of metal. This is known as the weld nugget. Because this sample has areas of continuous metal, the spot weld nugget, as well as two plates separated by a gap, the unwelded area, the signal from the transducer will respond differently based on these two areas. On a B scan, we can expect to see horizontal lines, representing reflections. The fused nugget area should interrupt these lines. On a C scan, the software will compile an image of the sample. A dark black area will show the fused nugget, while lighter gray regions represent unfused areas. The sample is placed into the immersion container and should be covered by water with a depth a little more than the focal length of the transducer. The transducer is then lowered down until it touches the water and is fixed in position. The scanner is turned on and the control software is launched. The green light indicates that a connection has been established between the scanner and the computer. Pressing A scan, then acquire, will bring up the real-time A scan provided by the transducer. The wave on the right is a signal reflection from the sample. As the transducer is lowered closer to the sample, the reflection will move to the left on the timescale, as it has a shorter distance to travel before hitting the sample and causing a reflection. As the focal point of the transducer comes closer to the sample, the amplitude of the signal will increase. By moving the transducer vertically toward or away from the sample, we are able to see a second pulse. The first pulse is a reflection from the top surface of the first plate, while the second pulse is a reflection from the bottom of the first plate. Since we are looking to focus on the gap between the two plates, we need to adjust the vertical position of the transducer until the amplitude of the second pulse reaches a maximum. The vertical green bar is known as the gates and will be used for creating the C-scan image. For the B scan, the transducer will only need to move along a single axis. The software will generate a grayscale B scan image. The white areas represent positive amplitudes, the black areas represent negative amplitudes, and the gray area represents zero amplitude. The first surface reflection appears as a horizontal line consisting of alternating black and white colors. The line dips down towards the middle. This is caused by a physical indentation in the sample created by heat and pressure during the spot welding process. Above the surface is just water, so there are no reflections and the B scan shows a purely gray area. Below the surface, we can start to get a better understanding of the sample's structure. The lines below the surface extend on the ends, but have a missing section in the middle. This is caused by the spot weld nugget. In this B scan from another sample, we are able to detect a reflected area within the nugget itself, likely caused by a bubble or an area of porosity. For C scans, the transducer will move along the two horizontal axes. It will move quickly along one axis and slower across the other. For each stroke of the transducer, a line for the image is generated. The time to complete a C-scan is proportionally related to the number of lines in the image. The size, and thus the time required to complete, can be adjusted in the settings menu. In this demonstration, the scan area was set to 15 by 15 millimeters. Once completed, the C-scan will give a visual representation of the spot weld. The dark black circular area is the nugget, while the lighter area surrounding it is the unfused plates. Since we know the size of the work area, 15 by 15 millimeters, we can directly measure the size of the nugget from this image.